Whoa, this is Mr. Tran with another AP tip of the week. So this week we're going to expand on more of the diagrams that you might have seen before. Okay, let's begin. So this week is super crucial. You will be taking a mock exam. That is your goal for Wednesday through Friday. You will need to also understand how this exam works. So what you see on this slide is the link to the interactive demo that is available for you. Please be sure to go through this demo from start to finish. You need to see how time elapsed. You need to see how to submit your exam. Read through each section of the demo carefully. You got this, y'all. So let's take a look at air pollution. This diagram is describing thermal inversion. The temperature gradient of the atmosphere is altered when the cool ocean breeze brings air to the Earth's surface. That is cooler air than the air at higher altitudes. This causes thermal inversion. The warm layer of air traps the cool layer of air close to the Earth's surface. The cold air ends up at the surface when the mountain blocked the morning sunlight from warming the floor, or the particulate pollution in the city blocks the sunlight from reaching the surface to warm. So that's thermal inversion. Cool, warm, and cool again. Let's see the production of photochemical smog. So you have nitrogen dioxide that naturally breaks up into nitrogen monoxide and a free oxygen atom in the presence of sunlight. The free oxygen joins an oxygen molecule in the atmosphere to form ozone. Ozone's production occurs during the daytime, like I said, and this is with a lot of sunlight. At night, ozone reacts with the free nitrogen monoxide to reform the oxygen molecule and nitrogen dioxide. In figure 3, this is where photochemical smog is formed with the basis of figure 1. So with what figure 1 did of nitrogen dioxide breaking up into nitrogen monoxide and a free oxygen atom, we have that process, but with figure 3, we also add in that nitrogen monoxide, NO, reacts with VOCs. Again, that reaction creates photochemical oxidants. And that's the thing that reacts with ozone to produce photochemical smog. We need to know how to read climatograms. The climatogram has two y-axes, one that shows precipitation in centimeters and one that shows temperature in degrees Celsius. Now, the bar graph represents precipitation. I'm writing it down. Bar graph equals precipitation, while the line graph represents temperature. Crucial, if you don't remember, I would write this somewhere or type it in your Wharton document. Here's an example of, again, another climatogram for you guys to practice reading. So we have temperature represented by the line, and then the bar graph would be the precipitation. Let's see the different energy production. Let's start with coal. Coal is sent through the boiler, and that's where coal is combusted, and then all that heat or energy is used to heat up water, which converts it into steam, and that steam is then taken to the turbine, and the turbine is now being turned by the steam, which then in turn turns the generator, which then creates electricity. Moving on to the nuclear power. A is the site of the control rods, which are used to regulate the fission reactions of the fuel rods. Okay, so again, A, control rods. B is containment structure. It contains You guessed it, radioactive reactions. So containment structure. C is where water is converted into steam. So the steam is what you see in C. And then D is the turbine. E is the generator. So the steam turns the turbine, which in turn turns the generator, which creates electricity. And then F is the condenser, which cools the water or the steam back into water, and this process continues again. Now diving into renewable energy generation. Let's look at hydroelectric power. It all starts with the intake. Okay, that water goes through and then it goes around and around to turn the turbine and it flows out. Well, this turning of the turbine turns the generator. Okay, and then that generator generates or creates electricity. Looking at wind power. The blades definitely represent the turbine if we need something similar to compare to. The blades turned and that motion is connected to the gearbox. That gearbox converts the motion to energy that the generator can receive. The generator is then able to convert that mechanical energy into electricity. Let's look at geothermal energy. It takes the heat naturally generated from the Earth's core to heat water. That water then turns into steam, which is then used to turn a turbine, which then turns the generator to create electricity. The steam goes off to a cooling tower before going back down a pipe to the Earth again to be heated up for another round. Finally, we have a hydrogen fuel cell. This allows for hydrogen to go in and react with oxygen to produce electricity through the synthesis of water. So step 1, hydrogen goes through a reaction layer and splits up into protons. These protons move across the membrane of the fuel cell. As the protons move, the electrons take a different route from that reaction layer. And that route is the electric current. And that current fuels something like the electric motor in a vehicle. The oxygen molecule is then split and combined with the protons from the hydrogen molecule to create water as a byproduct. Hopefully this has refreshed you on some of the concepts you have already learned. Remember, don't forget to do the checklist, which can be found in the AP exam day procedure discussion. What can also be found is the demo. Please go through the demo and see what it is like to take your AP exam this year. We will talk strategy soon. Have a good one.